Welcome back, ladies and gentlemen. We are now on question number 2, and so this diagram shows an electrolytic cell used for the extraction of aluminium at temperatures as high as 1000 degrees Celsius. Remember, aluminium is one of the most abundant metals on earth, yet it is expensive, largely because of the amount of electricity needed to extract it. Aluminium ore is called bauxite. The bauxite is purified to yield a white powder, aluminium oxide, from which aluminium can be extracted. Our first question, which is question 2.1, states the energy conversion that takes place in this electrolytic cell. Remember what we said when we were actually discussing electrolytic cells. We say that electrolytic cells are those types of cells which actually change electrical energy into chemical energy. So this one is an electrolytic cell. Therefore, it changes electrical energy to chemical energy. Question 2.2 says, is aluminium formed at the positive or at the negative electrode? Write down positive or negative only. Remember what we said on electrolytic cells. The signs of the anode and the signs of the cathode, which we have in electrolytic cells, are the opposite on those ones of galvanic cells. So this one is an electrolytic cell. As you can see here, we are having our positive carbon electrodes. Our positive carbon electrodes, they act as the anodes, right? And the negative electrodes which we have here, they act as the cathodes, which is the opposite which we have on galvanic cells. So in this case, yes, of course, our oxidation reaction occurs at the anode, as well as our reduction reaction occurs at the negative electrode, which is our cathode. So our question now says, is aluminium formed at the positive or negative electrode? It occurs at the negative electrode. Why? Just because that is where reduction is taking place, right? Then the question says this, question 2.3, use the table of standard reduction potentials to write down the half reaction for the formation of aluminium. That is question 2.3. Remember what we said. We have said that at our cathodes, that is where aluminium is being formed. Therefore, we are saying that we are having our aluminium 3 plus in aqueous form plus 3 electrons, and we form aluminium solid. So this one is a reduction reaction. Why? Because we are adding electrons there. So therefore we are saying that our half reaction which occurs for the formation of aluminium is aluminium 3 plus 3 electrons to aluminium solid, and this one, it occurs at the cathode, which is our negative electrode which we have here. Then question 2.4 says, explain why carbon dioxide gas is formed at one of the electrodes. Remember, our carbon electrodes are our carbon electrodes which we have there. They act as our cathodes as well as they act as our cathode as well as our anodes. But now what we are saying is our carbon will burn in or react with oxygen because of the high temperature to form carbon dioxide. That is, on question 2.4, we see to it that our carbon solid plus our oxygen gas, they are going to react to form carbon dioxide gas, right? So what we are saying is, we know that at our anode, we see to it that our oxide ions, they are actually being converted to oxygen gas. So what we have is our oxide ions in aqueous form, where it's going to produce oxygen plus 4 electrons. This one, as you can see, we have a lot of loss of electrons. This one is an oxidation reaction which is actually taking place at the anode. So at the anode we are producing oxygen. So this is the oxygen which is now reacting with our carbon electrodes. Therefore, we're going to produce carbon dioxide in the process. So that's why our carbon itself is, our carbon dioxide is formed at one of our electrodes. Then question 2.5, it says that why should the carbon electrodes be replaced regularly? Right, as you can see at our anodes there, we see to it that we have our carbon electrodes, they are being taken away by reacting with oxygen. Therefore, we are losing them. So there is need for us to actually replace them. So our carbon burns away or used up or oxidizes or loses electrons and needs to be replaced. And then in our question 2.6, write down 2 negative effects that the extraction of aluminium can have on the environment. Right, we have many of them, but all what we actually want is for you to give any 2 of them. We have what you call the ecological impact. Alright, we have the ecological impact, and under the ecological impact, we are going to have loss of landscape due to the size of the chemical plants needed. Secondly, we have the disposal of red mud, which we call iron 3 oxide, formed during extraction of aluminium oxide from bauxite into lagoons themselves, causing them to become unsightly, right? So we have also the environmental impacts. Number 1, carbon dioxide from the burning of the anodes contributes to the greenhouse effect or air pollution or global warming. So we see to it that the carbon dioxide, this one which is being produced, is actually going to have a problem in our environment, right? Secondly, we are going to have carbon monoxide is poisonous. It can also be produced, that is in the incomplete combustion. Then we have fluorine and fluorine compounds lost from the chloride. Remember, we're having our molten cryolite, which we have in this particular sense. So this particular molten cryolite, which we have there, can also have some environmental impact, right? During the electrolysis process is highly poisonous, right? Alkaline of red mud dams can drain into soil and contaminate groundwater. Pollution caused by power generation, that is for electrolytic process, using coal-fired plants lead to acid rain, or it can also enhance the greenhouse effects. And we also have noise pollution. So you can have any of those two negative effects to the environment, right? So that one is what we call the environmental impact of our pollution, of our extraction of aluminium, right? So stay tuned for question number 3 in order for us to understand our electrolytic processes. Thank you for now.